Welcome back to another video. Now we will discuss about the Hall effect. So this effect is used to find the magnetic flux density that a charged particle experiences. Basically, it is a device and also a process in which we use a slab of semiconductor. Why it is made of semiconductor material? Because we need lesser number of free electrons. That is why we use semiconductor material. This semiconductor is connected to a power supply. When current passes through from one point to another, in here I can say that current is flowing downwards and charges are moving or electrons are moving in downward direction. And this slab is placed in magnetic flux density that we have to find out. Here you can see that magnetic flux density is applied into the page. The cross here shows that the magnetic field is inwards. So when the magnetic field is inwards, these particles will experience force according to formula F equals to Q or E into V cross B. As both velocity and magnetic field, they are perpendicular to each other, so force will be maximum, and the formula we get F equals to E, V and B. By using left hand rule, we can find the direction of force as B. Here you can see that it is into the page and the velocity is downwards. So by using left hand rule, by placing the fingers of left hand in direction of velocity like downward and curling the fingers inward into the page like this, we get the direction like thumb will erect and it will be pointing towards the left. So when electrons are deflected to the left, on the left side excess negative charges will appear, and on the right side deficiency of charges will appear. So now you can say that magnetic force is acting towards the left side. Magnetic force FB, I can say that is acting towards the left side. But there is another force that is developed inside the slab, that is electric field. So all these electrons are moving through the slab. They will repel through this negative side of the potential and it will be attracted towards the positive potential. Electric force will be developed to this side. So in conclusion, you can say that electric force and magnetic force, there are two forces now. Magnetic force will attract the electron to this part, to this side of the plate. This will be magnetic force and this will be electric force. So if electric force is greater, then definitely these electrons will move towards the positive side of the plate, and if magnetic force is greater, then definitely they will go to the negative side of this plate. By equalizing both of these forces, we can find the potential created by the slab, and that potential can give us the value of a magnetic flux density. So here you can see that the electric force will be equal to E, capital E, and magnetic force will be equal to E, V and B. Both the E's will be cancelled out and electric field will be equals to VB. Now we can replace the formula for electric field. It will be by replacing equals to V by D here. Here D is the thickness of the slab, and the other term T will be the width of the slab. So E equals to V by D. By putting E as V by D, we will get V by D. This V is Hall voltage. Actually, this will be equal to velocity into magnetic field. So VH, this will be equal to VB, and dV stands for velocity of these electrons. So by using the value of drift velocity from drift velocity, formula for drift velocity is NVD is equal to I by NEA. By putting this value here, IBD by NE and area. So as we know that area equals to thickness into width, by replacing area as thickness into width, VHS equals to IBD divided by NE into thickness into width. So D will cancel out. Hall voltage will remain behind like this, IB divided by NE and T. From this equation, we can see that Hall voltage is proportional to B, and in order to get the large value of voltage, we have to get this denominator as small as possible. So in this denominator, we have N as number of electrons and T as thickness. So to get higher value of Hall voltage, we will have to lessen the number of terms. For that purpose, we already use a trick for semiconductor which has less number of charged particles. And also T thickness of the slab, it should be small to get higher value of voltage. So from this equation, we can find the value of magnetic flux density or Hall voltage, or even the current or thickness and number of electrons, all quantities that can be calculated from the question.